everyone. Welcome to my sunroom chat. Today I will discuss what I call the graviton matrix. This term refers to the dense concentration of gravitons that we can expect in the space about us. In order to satisfy the gravitational force of attraction between our Sun and the Earth, there must be a vast number of gravitons connecting the two bodies. A renowned physicist by the name of Dr. William Hiscock was a professor at Montana State University. He said in one of his articles that scientists would like to believe that the energy of a single graviton approaches Planck's constant. In my book, I use the rate that protons oscillate and the number of proton equivalents in weight for a body as a basis for calculating the number of gravitons created by matter. You'll have to read my book to get the details. I was able to show that this method yields joules per graviton that approaches Planck's constant. I calculated the energy per graviton for Earth's gravitons that penetrate the Sun. I did the same for all the planets in our solar system. The results are shown in the next slide. The question is, how close do the values come to Planck's constant? The negative sign in front of the number of joules shows it is a force of attraction.
In all cases, the gravitons are retracting through the Sun. The value of Planck's constant is shown on the left. When a graviton penetrates the Sun and retracts, it pulls on the Sun and uses energy. The energy per graviton is shown in the center column. Here we see that indeed the energy per graviton approaches Planck's constant. Notice the joules created per graviton increases the farther the planet is from the Sun. Because Mercury is close to the Sun, its gravitons tend to penetrate the Sun at an angle. When these gravitons retract, they pull on the Sun with less efficiency. Neptune is a great distance away from the Sun, and its gravitons penetrate the Sun in parallel. Because none of the gravitons are pulling at an angle, they pull with maximum efficiency.
This data indicates that the method I used to calculate the number of gravitons is likely in the ballpark. If our Sun were 130 times denser, the joules per graviton would reach Planck's constant, and this would allow a planet's gravitons to expend maximum energy. Using this same approach to calculate the number of gravitons, I did calculate the density of gravitons at Earth's surface. I expressed the density as a number that passed through a square centimeter. That's about the size of this little piece of paper, or about the size of your small fingernail. The number of gravitons created by Earth in the space about us is shown in the next slide.
Earth is a very large body close at hand, and for this reason it contributes the most gravitons at Earth's surface. The number is immense. 1.6 times 10 raised to the 56th power. That's 16 followed by 55 zeros that pass through just 1 square centimeter. This is the number necessary to explain the gravitational force of attraction between Earth and Sun. It is also the number necessary to explain the graviton matrix and virtual elastic string theory, including relativity.
Of course, Earth is not the only source of gravitons. Our Sun and all the planets and moons in our solar system contribute vast numbers of gravitons at Earth's surface.
Our Sun contributes a huge number in the space about us, although more than 1,000 times less than Earth. The Milky Way galaxy is composed of billions of stars, and they contribute gravitons in vast numbers, and they are traveling in all conceivable directions. This is also true for the other galaxies in our local group. For example, the Andromeda galaxy has 1 trillion stars, and it contributes a huge number of gravitons at Earth's surface, even though Andromeda is 2.5 million light years away.
It takes 2.5 million years for a particle of light from Andromeda to reach Earth, but it likely takes less than 1 second for a graviton to travel the same distance. As you can appreciate, the graviton matrix consists of a vast number of gravitons crisscrossing in all directions. They form a veritable fabric in space. At this point, you're probably wondering why we personally can't detect the gravitons. if our bodies and the area around us contain a vast number in every square centimeter?
There are three important reasons why we can't sense the graviton matrix. First, we can't see them because all the gravitons in 1 cubic meter would weigh less than 1 electron. They would be far less visible than the air molecules that surround us. Second, we can't feel them. This is true because they weigh almost nothing and they are extremely long strings with perfect elasticity and great flexibility, which means we easily brush them aside as if they don't exist. And they have virtual properties.
If I move my arm aside like this, all the gravitons in this area have now been regenerated, and the gravitons that I pushed aside have now disappeared entirely and new ones have reappeared. With every step we take, old strings disappear and new strings are generated. There is a great deal of evidence for the graviton matrix. Indeed, the graviton matrix is one of the most important concepts in virtual elastic string theory. It is absolutely necessary to explain relativity and numerous other conundrums in physics. For you to better understand and appreciate this statement, this movie ends with a list of conundrums whose solutions depend upon the graviton matrix. I leave it to you to explore. I discuss all of them in my book. Thank you for listening to my sunroom chat. I invite you to read my book and stay in touch. Now for the list I promised.